Do you want to know how to avoid 10,000 tons of CO2 emissions per year in the steelmaking industry? HI4S. Heat it yourself for sustainability. Circularity in energy-intensive industries. The European Union, with the goal of becoming the first climate-neutral continent by 2050, is focusing on the decarbonization of sectors where energy is most intensively used. Industrial processes. In industrial processes, 20 to 50% of that energy is typically lost as waste heat, released in the form of gaseous or liquid streams. In electric arc furnace (EAF) steelmaking, a significant amount of hot off-gas is released into the atmosphere after being cooled down and treated to reduce pollutants. As a result, the thermal energy is wasted and additional energy is consumed to lower their temperature before release in the air. This waste heat has been the target of the LIFE HI4S project with the aim to recover and repurpose this energy. After 4 years of research and development, LIFE HI4S project is finally gathering test results, technical and environmental indicators about the feasibility and implementation of the model. The LIFE HI4S project focused on the design, construction and validation of an innovative, cost-effective system for combined heat and electricity generation to enhance energy efficiency and sustainability in EAF steelmaking by recovering and reusing off-gas heat. The designed LIFE HI4S system integrates several key technologies. High-temperature ceramic filtering system, to which the dirty waste heat stream is redirected to remove solid particles and obtain a hot, clean stream. Thermal Energy Storage System, TES. Inspired by the H2020 ReSlag project, this system uses steel slag as a thermal storage material to manage the intermittent nature of off-gas heat. Scrap dryer. A container where steel scrap is dried and preheated using hot off-gas before it enters the furnace. This reduces the natural gas consumption associated with the conventional preheating of the scrap. Organic Rankine Cycle, ORC, which is the equipment that converts the recovered thermal energy into electricity using a low-impact working fluid supplying power to the steelmaking plant itself. However, despite the project's ambitions, can LIFE HI4S truly contribute to the decarbonization of the steel industry? And if so, to what extent? And how can that be assessed? The answer is provided by the Life Cycle Assessment, or LCA, a robust and reliable analysis tool that examines the environmental impact of a product, process or service. LCA considers the entire cycle from raw material extraction to end-of-life disposal or recycling. This holistic approach evaluates environmental impacts across various stages, including resource consumption, emissions and waste generation. By dissecting each phase, LCA highlights critical environmental hotspots and areas of significant impact. The LCA allowed to evaluate and quantify the environmental impacts associated with the LIFE HI4S project across its production, integration and operational stages. The analysis compared two scenarios: a conventional steelmaking process without the LIFE HI4S system, a steelmaking process fully integrated with the LIFE HI4S technology. The analysis followed a cradle-to-gate with options approach, considering the environmental impact of the LIFE HI4S entire infrastructure, from raw material extraction and processing to manufacturing, assembly and transport to the installation site. The use stage impact, which refers to the actual operation of the LIFE HI4S system. This is where the LIFE HI4S implementation really makes a difference. The system captures and reuses off-gases that would otherwise be released into the atmosphere, using them to preheat steel scrap before it enters the electric furnace. A portion of the recovered heat is also used to generate electricity, which is fed back into the steelmaking process. In a traditional setup, all electricity is drawn from the grid, while natural gas is employed for scrap preheating. With LIFE HI4S, some of that energy is recovered internally, reducing reliance on external power sources and significantly lowering the system's environmental impact. End of life of the HI4S components is excluded from the analysis. The LCA was carried out for two versions of the LIFE HI4S system, a small-scale pilot plant which recovers several hundred megawatt-hours of energy per year, and a larger industrial-scale system designed to recover tens of thousands of megawatt-hours annually. The analysis has been performed by LCE, a LIFE HI4S partner, with primary data collected through the collaboration of the technical consortium, while secondary data were sourced from international databases. Where necessary, assumptions were made to address data gaps and ensure methodological consistency. All the data were processed using professional LCA software, which generated a comprehensive set of environmental impact indicators. In terms of climate change, the results show that the LIFE HI4S system offers a clear environmental benefit, significantly reducing CO2 emissions compared to conventional steelmaking practices. In fact, at pilot scale, the LIFE HI4S system avoids 50 tons of CO2 equivalent emissions each year. At the industrial scale, the avoided emissions rise to more than 10,000 tons annually. The LCA demonstrates the substantial environmental potential of the LIFE HI4S technology in contributing to the decarbonization of the steel industry. By capturing and reusing thermal energy that would otherwise be wasted, the system significantly reduces the carbon footprint of steel production. The LCA confirms that both the pilot and upscaled LIFE HI4S systems deliver notable environmental benefits. Over the assumed 25-year service life of LIFE HI4S system, it offers a highly favorable environmental return on investment, supporting its adoption as an effective and credible solution for more sustainable steelmaking.